This is the last problem, problem 6 of section 3.3. Consider this function cosine x minus root 2 by 2x. This function has two critical numbers, a and b. One is less than the other. Give them. Then the question wants you to find the second derivatives at each of these. Using this, you want to inform whether it's a local max or a minimum, or local max or a minimum at b. All right. So cosine x minus root 2 by 2x. Okay. So I've done the problem here essentially. Cosine x minus root 2 by 2x. First derivative. Derivative of cosine is negative sine x minus root 2 by 2, because that x is just a linear term, right? Now, how do you get critical numbers? You want your derivative to be undefined or derivative to be 0. Okay, that's how you get critical numbers. Now notice, because this is sine, negative sine, it's a wave which is defined for all real numbers. So f prime is going to be always defined. So this undefined part does not apply. So the only way of getting critical numbers is by setting derivative equals 0. In other words, you are going to plug this equals 0. So move the negative root 2 over 2 to the other side. Negative sine x is positive root 2 over 2. Move the negative above over to the other side. So that gives me sine x is negative root 2 over 2. That tells me x equals 5 pi by 4, 7 pi by 4. How did I get this? See, this is trigonometry. All right. So you need to be very aware, very good, knowledgeable about the trigonometric unit circle, trigonometric values on the unit circle. So when you go to your contents on Blackboard, yes, our course on Blackboard, there is this folder called most important files. Go there. I have uploaded the unit circle file for you. Okay. For me, it immediately opens, but for you, it might download it below. Okay, that's okay. Another place you will find it is in our Dropbox for the Math 31. You will find most important files there, and I have put trigonometric unit circle there. Okay, so let's figure this one out. Now I'm looking for x values such that sine is negative root 2. If you remember the unit circle, sine is the second derivative. So I want second derivative to be negative root 2 over 2. So it won't be above, it will be below. Here is negative root 2 over 2 and here is negative root 2 over 2. Okay. So one angle is 5 pi by 4. The other angle is 7 pi by 4. That's all I have done. Okay. Now, so that gives me the two values of x. So these are my critical numbers. Okay. So the smaller one is 5 pi by 4. The larger one is 7 pi by 4. Okay. So 5 pi over 4, 7 pi over 4. Okay. Now I want to find the second derivative. So second derivative, my first derivative is this. So second derivative will be negative cosine x, and this is just a constant, doesn't fetch me anything. Now plug in 5 pi by 4 for cosine x, and don't forget there is a negative outside. So what happens at 5 pi by 4 for cosine, right? 5 pi by 4. Go back to your unit circle. 5 pi by 4 cosine is negative root 2 over 2. You notice that? But I have a negative in my expression, so overall that becomes a positive root 2 over 2. Likewise, 7 pi by 4 is here. Cosine is positive. Cosine is the x coordinate, and with a negative outside becomes negative. Okay. So what does that say? So f double prime at the first guy is positive square root 2 over 2. On the other side, it's going to be negative square root 2 over 2. Okay. Now, what does that say about my maximality or minimality? Second derivative is positive means f is concave up. So here, no matter what my value be, I am concave up. So what kind of picture do I get? I get a local minimum. Okay. So at A, I have a local minimum. Likewise, here, second derivative here is negative. So what does that tell me? I am concave down. All right, concave down. That is, this gives me a local max. Okay. All right, so the next set of lectures will be on section 3-4. Until then,